Have you ever asked yourself, what was here before? What was Earth like before I existed? What people, what animals have moved through the same space I'm in now? How long has everything been here? Just how old is this place we call home? Hi, I'm Marcus Lloyd, and welcome to Unlocking the Mysteries of Genesis. In this series, we've been looking at the first book of the Bible and finding there's more truth in it than we may have thought. Today, we're going to explore what Genesis says about the age of Earth and see how it stacks up to the scientific evidence. When we ask, how old is Earth? We're really asking a history question. What is our planet's history? How long has it been here? How was it formed? Unfortunately, no human being was around to see it happen. The best we can do is look at clues and test them with modern science and technology and draw conclusions based on the results. All scientists work with the same data or evidence, the same chemical, biological, and physical clues. They find information in fossils embedded in geologic formations like this trilobite embedded in shale. They also examine current processes that impact our Earth, like sedimentation, erosion, and plate movements. For example, the scientists know that many parts of the continents are covered by geologic strata, layers of rock stacked one on top of another, like these books, building up over time. They also learn from studying natural processes, such as the rate of decay in organic substances like plants and animals. And they can learn by studying the written records of ancient civilizations. These clues are available for all of us. The key is how we interpret the information we get from them. So, how old is the Earth? Let's look at the data and see how both secular and creation scientists interpret them. But instead of talking about it, how about a little field trip? A trip back in time. Our journey takes us all the way back to the beginning, to the creation. But how far back was that? How long will it take us to get there? I'll tell you what, I'm definitely packing a lunch. The age of Earth is a fundamental question, and to find the answers, we turn to both science and the Bible. In both cases, faith comes into play. Let's take a look at some of the methods that scientists use to estimate Earth's age. Age is not something that's always determined exactly. For instance, without your birth certificate or the testimony of your parents, how do you even know your own age, let alone someone else's? All scientists start with certain assumptions about the past, and then use faith in those assumptions, together with geology, physics, and chemistry, to make certain calculations about the planet's age, or more specifically, Earth's rocks. This is called geochronology. Now, there are several different ways to do this, and we sometimes get different results. The clocks that scientists use to estimate the age of rocks have things in common. They all assume, by faith, a constant process rate, like the sand in this hourglass. We assume that will always fall at a constant rate. And next, you need to have what's called a closed process system, like this glass. Nothing getting in there to interfere with the measurements. And finally, scientists have to begin with a known process component. Again, like the sand. You know how much you start with, so you know how much time passes as it falls. Did you get all that? A constant process rate, a closed process system, and a known initial process component. Simply speaking, if you know how much sand you have, and you know how fast it falls, and you know that it always falls at a constant rate, then you can calculate the time. But we'll talk more about that later. Well, now it's time to get going. Are you ready for an adventure? Let's explore the Grand Canyon for clues about the age of the Earth. We come to the Grand Canyon because it's almost as if the Earth has been cut open for us. This is the perfect place to see a cross-section of time. The strata in the walls of the Grand Canyon show the Earth's layers, one stacked on top of the other. The more recent layers on top and the older material below. And the deeper we go into the canyon, the further we go back in time. But how long did it take for all of this to build up? When was the first strata formed? Let's ask an expert.
Secular scientists say with great confidence that the rocks in the Grand Canyon are in the inner gorge more than 1 billion years old, and these layered sediments between 270 and 540 million years old. They base these estimates on the decay of radioactive elements like uranium and their measurements of how fast uranium decays into lead and helium in the laboratory. These scientists assume that the rate they measure in the laboratory today has been constant since the Earth came into existence. However, about 10 years ago, some of my colleagues and myself found powerful evidence that the rate that uranium decays has not been constant in the Earth's past, but has been as much as 1 billion times higher than we measure it to be today. This has profound implications. It means that this assumption that the secular scientists have been using for the last 100 years is wrong. The implication for the rocks in the Grand Canyon is that these rocks are not hundreds of millions of years old, but only thousands of years old. But what about carbon-14, the method that most people are familiar with? Well, first of all, carbon-14 is used to date the remains of dead plants and animals and not rocks directly. Carbon is present in every living thing. Carbon has 3 isotopes. Carbon-12 and carbon-13 are stable, but carbon-14 is radioactive. Carbon-14 decays into nitrogen-14 with a half-life of about 5,730 years, meaning half of it will disappear in that time. Plants take in atmospheric carbon. Animals eat the plants, and this introduces carbon-14 into their bodies. As long as the organism lives, it replenishes the amount of carbon-14 in its body, and the ratio of carbon-14 to carbon-12 remains constant. After the plant or animal dies, the carbon-14 in its cells decays back to nitrogen without being replaced, while the carbon-12 and a tiny amount of carbon-13 remains. The amount of carbon-14 as compared to the total amount of carbon in an organism will yield a calculated time since the organism stopped absorbing carbon-14. This age estimate is the calculated time since the organism's death and thus the calculated approximate age of the specimen. But an astonishing discovery, this time made by the secular scientific community over the last 30 years, is that carbon-14 is routinely found at significant levels in fossils that are supposedly tens to hundreds of millions of years old. But compared to those timescales, C14 is like a flash in the pan. There should be no carbon-14 detectable in any living thing older than 100,000 years, or 1/10 of a million years. What this implies is that all fossils are not millions of years old, but only thousands. And all the sediment-bearing layers of rock are only thousands of years old and not millions, including these we see in the Grand Canyon. And this implies that the Grand Canyon almost certainly has to be the product of the year-long Genesis flood just a few thousand years ago.
The secular dates of these rocks depend on one thing: uniformitarianism. Has everything always happened at a uniform rate? Has sand always fallen at a constant speed, like the second hand of a clock, steadily tick, tick, ticking? Or has it sometimes gone very fast? If it hasn't been constant, well, that's a huge problem for the uniformitarian outlook. Scientists have found soft tissue as well as DNA in fossils, but we know both soft tissue and DNA degrade within hours after death, and certainly after years and centuries. So why do they still show up in fossils that are supposedly millions of years old? Don't worry, we'll get to the bottom of this. To find some answers, let's head deeper into the canyon, closer to the beginning. The prevailing theory is that the Grand Canyon was carved by the Colorado River over millions of years. But let's look at another hypothesis. What if all this didn't happen over millions of years? What if these strata were formed suddenly, catastrophically, like when a volcano blows?
The idea that sediment layers can form quickly was documented in a dramatic way in 1980 with the eruption of Mount St. Helens. The initial blast was a horizontally directed steam explosion with the power of 20 1-megaton bombs that flattened in seconds 230 square miles of lush conifer forest. Following that, there was 9 hours of eruption of mostly vertical ash driven by steam, that much of which fell down vertically back to the ground and resulted in a horizontal pyroclastic flow, hot volcanic ash flowing at roughly 100 miles an hour. This material formed orderly layers of material, just sediment layers, some just a fraction of an inch thick. And you had tens of feet, hundreds of feet thickness of this material, demonstrated very clearly how rapidly ordered layered sediments can form. Moreover, a single mud flow following the eruption resulted in the carving of a canyon 1/40th the scale of the Grand Canyon in one afternoon through this layered debris. So it also demonstrated that canyons can be cut very rapidly, within hours.
So maybe there are flaws in the ways that scientists calculate the age of things. If you go to practically any museum of natural history, they'll tell you that dinosaur fossils are tens of millions of years old. But how can they be sure?
The contradiction, though, is that you have these specimens, coal, wood, even dinosaur bones, that are supposed to be tens or even hundreds of millions of years old, and yet there's still detectable carbon-14 in them. And that just should not be the case. And we think this is illustrating that one of the key assumptions of the method is wrong, the assumption that the decay rates have been constant. Because if you assume that the decay rates have been constant throughout Earth history, you will get millions and billions of years for those dates. But that very assumption leads to a contradiction. If the decay rates have been constant throughout history, then those fossils really are millions of years old, and there should not be any carbon-14 in them, or at least none that we can detect. But there is. And so that's telling us, we think, that there's a problem with the method. Another indication that there's something wrong with the method involves these little crystals called zircons that we find in granite. And within the zircons, you have uranium-238, which is radioactive. And it goes through this multi-step process where that uranium-238 is transformed into lead, a particular isotope of lead. Now, if you look, for instance, at the amount of lead in the zircons, you can figure out how many years of decay that would be at today's rates. And it's about 1.5 billion years. So if you're looking at the lead in the zircons, you would conclude that it's about 1.5 billion years old. But there's another decay product that occurs in this process, and that's helium. When the uranium turns into lead, you have helium nuclei being produced, basically helium atoms minus the electrons. And so they eventually, along the way, they're going to pick up a couple of electrons and they will become full-blown helium atoms. Well, these helium atoms, they don't react very well with other substances, and it's very easy for it to leak out of the zircons. If these zircons really are 1.5 billion years old, why is it that we still see large amounts of helium within the zircons? Because if they're really 1.5 billion years old, most of that helium should have leaked out. So here we have a contradiction within a single method. You have two decay products. You've got lead, you've got helium, and they're giving you two different ages for the zircon. And again, how do you resolve that paradox? Well, one way to resolve it would be if the decay rates have changed in the past.
Because of the types of rocks and fossils found in these layers, experts used to think that it took millions of years for these canyons to form. Now some have come to believe in a catastrophic theory of formation that says it all happened very quickly, violently, like from a global flood. Now, I told you that we'd get to the bottom of these mysteries, and I think that we have. And the answers lie just below our feet and stretch out for hundreds of miles in every direction.
The lowest horizontal lying sediment layer in the Grand Canyon is known as the Tapete Sandstone. From the south rim, one can trace this layer from one horizon to the other. It occurs not just here at the Grand Canyon, but this Tapete Sandstone layer and its equivalents cover a large part of North America. The erosional boundary just below the Tapete Sandstone is commonly known as the Great Unconformity. It's an erosional discontinuity, beveled off the rock beneath it before the Tapete Sandstone was laid down. Just above that boundary, in the lower part of the Tapete Sandstone, we find large boulders. There's one boulder 15 feet in diameter weighing 200 tons in the lower part of the Tapete Sandstone. It boggles the mind to imagine a water process, moving water, able to rip up boulders that large, roll them along, round off the edges, and deposit them in a big layer of boulders, and do it all over the North American continent. So this leads creation scientists like myself to conclude that this must mark the onset of the Genesis flood.
So the evidence suggests that the different strata might have been laid down in a much shorter period of time than we thought. If the rate of change in the Earth wasn't constant, and if these strata didn't form slowly over millions of years, then the assumptions we've been using for our age estimates aren't reliable. And that means that our planet is much younger than secular scientists say that it is. Let's see what the Bible has to say. In Exodus 20:11, we read, "For in 6 days the Lord made the heavens and the earth, the sea and all that is in them, and rested the seventh day." That's an important point. Again, in Exodus 31:16-17, God says, "Therefore the children of Israel shall keep the Sabbath. For in 6 days the Lord made the heavens and the earth, and on the seventh day he rested and was refreshed." But what is a day? Can't God define day however he wants? A day being a day, or a day being a million years? The Bible gives us some clues. In Genesis 1:4 and 5, God gives us his definition of day. God divided the light from the darkness. God called the light day, and the darkness he called night. So the evening and the morning were the first day. We can also work backwards to determine an approximate age of the earth by using the historical events described in Genesis, and learn how we became many people and how we formed many nations. So the Lord scattered them abroad from there over the face of all the earth. As we'll see in future episodes, modern archaeology combined with history matches up with the biblical accounts. And we know from historical evidence where the nations were. So now our Bible is becoming our history book, our earth clock. We'll also explore this question of day from an astronomical perspective, and we'll see how distant starlight supports the theory of a young universe. Now, many of you are probably asking, why do I need to know this? Why does it matter whether Earth was created billions of years ago or only thousands? What difference does the time make? It matters because of this. If the Bible is wrong or misleading about time in its very first chapters, where else was it wrong? If God was just being metaphorical in the beginning, then how are we supposed to know when the Bible is being true or when it's just being literary? Are we just supposed to pick which parts of the Bible we want to believe? How do we know that creation happened the way the Bible said it did? If it's all just random chance, if life was just a happy accident, a fluke, then the biblical scriptures have no meaning. But just take a look around you. All of this was not created out of chaos, for God is not the author of confusion, but of peace. And now the beginning leads us to the end of this journey anyway. And we didn't have to go back billions of years either. The evidence we uncovered today suggests that the dating methods that most scientists have been using are flawed, and that the age of the Earth may be counted in thousands rather than millions of years. And this matters because knowing that there's scientific evidence that backs up what we know in our hearts to be true strengthens our faith. And this matters because knowing how we got here helps us understand who we are, why we're here, and how we should live our lives. I'm Marcus Lloyd. Thanks for joining me in this episode. And our next show, we'll take a closer look at dinosaurs because they raise big questions about faith. For a long time, scientists believed that these creatures roamed the planet tens of millions of years ago. But modern technology is leading us to question these findings. Why is it important that we get accurate information on the age of dinosaurs? We'll come back and we'll look closer into this and other mysteries contained in the book of Genesis.